Hi, everyone, and welcome. We have a very special guest on the live stream today, and we will be talking about a new product released by Google recently, a couple months ago, the MCP Toolbox for databases. So once again, just type in the comments, let us know where you're joining from. And yeah, I didn't introduce myself, by the way. I'm Mira. I'm a senior developer advocate here at MongoDB. And yeah, I'm looking forward to sharing this 1 hour with everyone here. We have a lot of exciting content for you today, so please make sure to join in, stick around until the end. We will be not just discussing, but also seeing a live demo about the MCP Toolbox for databases, which is a new GenAI product released by Google.
Hey everybody, my name is Kurtis Van Gent. I'm the lead for MCP Toolbox for databases. I'm joining from Denver, Colorado. So I'm excited to be here with you today to talk a little bit about Toolbox and how MongoDB works with it today. So should we start with the slides?
Yeah, let's go ahead. Let's dive right into it.
All right, so like I mentioned, my team works on a product, an open source product called MCP Toolbox for databases. We recently collaborated with MongoDB to add support for MongoDB as well. So I'm going to kind of go through a bunch of things and we'll talk about what exactly that means. So we'll be going over a few things. First is we'll do some background information, hopefully review for most folks. We'll talk about agents, tools, MCP, and how they all fit together. Next, we'll talk about the MCP Toolbox for databases, how it's different from other MCP servers. And then we'll transition to using Toolbox with MongoDB, go through a couple of examples, show you what tools Toolbox has for using MongoDB. And then finally, we'll transition over to a demo that Mira is going to present. And then we'll have a Q&A at the end where you folks can ask any questions you have about anything we've talked about today. So first of all, let's start with agents, tools, and MCP. Oh my. So first of all, let's all get on the same page with what an agent is. I feel like everyone has a slightly different definition, but an agent, to me at least, is an application that reasons on how best to achieve its goal based on inputs and tools. And there's really three key components. You kind of need to understand how they work together. Number one, you have the model. So I think everyone understands what an LLM is. They've seen the rise of ChatGPT and Gemini and LLMs like that. And the models are a really important step because they're kind of like the brain. But then you also have the orchestration, and the orchestration is what ties everything together. So it handles things like what instructions are being passed to the model, what memory it's keeping track of, what reasoning and planning model it's using, things like that. And then finally, you have the tools. And the tools are a really important part of the agent because the tools are what makes an agent an agent. They allow the model to extend its influence beyond just text and do things like call APIs, call functions, interact with databases, and talk to other agents. And so these three things are really kind of what make an agent and give it some autonomy out of just kind of generating text for you. So tool calling is a really important part of agents today. Specifically, all of the tool calling today is built on the React architecture, where you have this pattern of observation, thought, and then action. And the way this works is you start by asking the LLM a question, and you ask it to prompt in this specific pattern. So you say, I'm going to ask you a question. I want you to follow through with thought, action, observation over and over again until we get to the final result. And so how the agent interacts with that is it does thought, which is kind of like chain of thought prompting, where it speaks aloud what it needs and what it's trying to do. Then it moves on to action, which is a specific function call or a tool call under the hood along with some parameters. At that point, you pause generation. You go and execute that function call. You take whatever the result of it back and you feed it into the model as an observation. This allows the LLM to interact with APIs and other things that normally it wouldn't be able to do just with natural language. So an example of this is on the right-hand side. You can see we ask, what is the capital of Japan? The thought is, I need to find the capital of Japan. I will use my search tool. The action is search, pass in capital of Japan. At this point, the orchestration framework will pause generation. The model is going to wait till it gets the result back. Someone's going to go execute a Python function somewhere. It's going to call an API. It's going to look up something in a database. It's going to come back with a result that says Tokyo. That result gets fed back into the prompt, and we ask the model to keep generating. At this point, it sees, hey, I had a thought, I had an action, I had an observation. Now I have the answer to my question, so I can respond with my final answer. The capital of Japan is Tokyo. So how does MCP play into this? So MCP is an open protocol that standards how applications provide context to LLMs. So an example that folks like to use is, MCP is like USB-C port for AI applications. The idea being that I can create an application that works with any USB-C port, and anyone else that has another USB-C port can integrate with it. This gives you this standardized way to connect models to different data sources and tools. This is a really powerful thing because MCP essentially decouples the ability to use tools from the ability to create them. It means that you don't have to write new tools for your application every single time, but that you can create tools and share them between different agents, different people, different companies, a lot of things like that, which empowers developers to write applications that are independent from the tools. They can focus on the agents and the prompts, and they can write applications that discover and consume these tools dynamically. There's two main use cases that we're seeing today. You see agents for developer assistance. So this is by far the most popular today, which is you have development environments, things like Gemini CLI, Cursor, Windsurf. All of these have built-in agents that help you develop and author your code more quickly. With MCP, these agents get supercharged. They get a bunch of access to tools that allow them to access and edit information. These tools can do a bunch of different things. We see a lot of MCP servers like Context7. It allows you to provide access to documentation specific to the versions of the libraries you're using. We see things like GitHub that provide context from issues and PRs. Or you can interact with databases, which allow you to understand how your database's schema looks like, what state is in the database already, and gives your agent more context for how to interact with the application correctly. So I tend to call these build time tools because they're tools that enable you to build faster and better than before. And they're a little bit different than our second use case. So our second use case is agents for applications. So this is where you have like an orchestration framework such as ADK or LangChain or Pydantic AI that allow you to build your own agents. With MCP, you can share and distribute those tools across your agent applications, allowing you to optimize development and reduce operational overhead. So you can essentially take an agent like ADK and plug in tools that somebody else, maybe another team, maybe just another person has written, and you can deploy those independently. So if you need to push changes to your tools, it doesn't require you to push changes to your agent. You can just kind of update these automatically, and your agents will adapt as needed. So I like to call these runtime tools because these are tools that enable your agent to solve new or unique problems at runtime. They're not helping you build things, but you're building an application with them, or you've built an application that uses these at runtime. And the reason it's important to distinguish between these two use cases is build time tools and runtime tools have lots of different properties. Build time tools tend to be more generic and act on behalf of the developer who's a trusted resource, while runtime tools tend to be more specific and act on behalf of a user who's maybe an untrusted entity. So with that segue, let's talk a little bit about MCP Toolbox for databases and how these two types of tools fits into the bigger picture. So MCP Toolbox for databases supports both use cases. You can use it for building agents for applications. You can also use it for agents for developer assistance. We support way more databases than most MCP servers. We've got support for more than 30 different data sources today, including a bunch of open source ones. MySQL, Postgres, SQLite, Valkey, and of course, MongoDB was recently added. The whole point of Toolbox is to make developing tools for databases easier and more secure. So before MCP and before things like Toolbox, you had to write different logic for every single framework you were using. Whatever framework you were using, you'd have to write different logic that said, this is how I want, LangChain to interact with MongoDB. This is how I want Llama Index to interact with Cloud SQL. And so this created a lot of problems, which is you were duplicating a lot of code. A lot of things were different. When things would change over time, you'd have to update things in a lot of places. Today, it's kind of one uniform thing. What Toolbox does is essentially create this nice platform with baked-in observability, baked-in security, and of course, scaling, making sure that like when you need your agent to scale, Toolbox will be able to help you do that. So how is Toolbox different? MCP Toolbox for databases is very popular and it's widely used today, unlike a lot of MCP servers. We've got over 11,000 stars on GitHub. We've got thousands of monthly active users. So you can go with confidence that other people are running into issues before you and we're trying to get them fixed. It's specifically designed and optimized for databases. It provides a lot of production-grade features that are specific to databases, things like connection pooling. So depending on which database you use, this can be a really big deal. Postgres specifically, you want to make sure that you manage and reuse your database connections for better performance. This also helps with scaling. We also handle authentication and authorization. We have a really flexible framework that allows you to pick how you want to authenticate and authorize. And we support a lot of different authentication and authorization methods depending on which database you're using. And finally, observability. So we have built-in support for OpenTelemetry, which means that you can monitor and trace anything, export it to your favorite provider, and look at those logs to kind of understand how things are operating, how many tool calls are successful, which tools are being called and which aren't. Toolbox is also highly customizable, especially compared to a lot of MCP servers out there today. We have kind of two different modes. We have a pre-built configuration that gives you access to those build time tools out of the box, but we also have a custom tools provided via tools.yaml that gives you a ton of control over customizing and mixing and matching which sources and tools you want to use to connect to. So here's an example of what a pre-built config looks like. So if you want to use Toolbox out of the box, you want to do any configuration, you can essentially specify a pre-built configuration, which comes with a bunch of tools for you. All you have to do is specify some environment variables that tell you like how you want to connect. So this example here is for Cloud SQL for MySQL. You can specify a project ID, region, instance. You can either use IAM authentication or you can specify a username and password. This will bring Toolbox up. It'll have a handful of tools that are familiar for developer assistance, and then you can get started using it. We also provide the custom tools.configuration. So this is where you can tell us exactly what tools you want and build very specific things. And so we have a couple of different things. The first is we have source. A source represents a source of data that a tool can use. So technically, this usually represents like a client or a connection pool. It encapsulates how you want to connect to the database. It's things like the IP address, what credentials you want to use, all of the things like that. We also have tools. So tools are an action that are usually executed on a source. So the tool is going to be a description of how and when in natural language you want the thing to operate. It's going to include things like parameters. It's going to include a bunch of other things like the descriptions for those parameters, a SQL statement you want to run on their behalf, things like that. This allows us to do things like SQL injection prevention. We make sure that we used escaped parameters. So like when you're passing parameters into the tool or when the agent is passing parameters into the tool, we can make sure that it's not trying to do funky things and only executing what it's supposed to. Last, but definitely not least, we have tool sets. And what tool sets are a logical grouping of tools. So you'll see this where you have a bunch of tools, but too many tools can actually slow an agent down or make it more inaccurate. Tool sets let you group tools. So you can specify 20 or 30 or 40 different tools. And you can say these 10 are for agent A, these 10 are for agent B. And maybe there's some overlap in there. Maybe they both have the same read or write tool. You don't want to rewrite that tool. So you can just share it between them by using a tool set to separate out which tools go where. So custom tools are really important because guardrails are an important part of building accurate and unique agents. One problem that's really common today is a new variation of the confused deputy problem. Essentially, an agent can get tricked into doing things that it shouldn't. You can hide these in the user's prompt. You can trick the AI into looking up the wrong information or executing the wrong statement, something that the user shouldn't have access to. So instead, what we should do is apply the principle of least privilege. In order to minimize the risk, you should make sure that the AI agent doesn't have more permissions than the person using it, and that it's limited access to tools based on who's talking to it, and that it shouldn't be able to access those tools unless you're sure that it's information the user should be able to see. Essentially, you should treat the agent as an untraced entity because it's probabilistic. What custom tools can do is give you guardrails. Guardrails essentially say, hey, instead of giving the AI direct access to this database or API, we're going to write a custom tool that limits exactly what it's allowed to do. By limiting what it can do, that limits the chance for things to go wrong. It doesn't really matter if you can trick the thing into trying to drop a table because it doesn't have the ability to drop a table or delete information. And so custom tools are really useful in that regard because they allow you to prevent your agent from being tricked. They give you guardrails that prevent things from going wrong if someone's done the wrong thing. So if you want to kind of understand more, I'd recommend you check out a blog that we shared on this topic. You can scan that QR code and take a look at some more prominent examples. Toolbox also has its own SDKs. So of course you can use any MCP client out of the box if you want, but we also have our own SDKs that are smoother and a better experience than some of the official ones. We have support for Python, TypeScript and JavaScript, and of course Go. So you can use all of these SDKs to access a lot of the features that we have built on top of MCP, things like tool sets and some of the authentication features for a more streamlined experience. They let you load tools. We have lots of integrations with different orchestration SDKs. So we have built-in support for things like LangChain, Llama Index, ADK, and GenKit. So these work pretty seamlessly with those things and kind of work out of the box. So now let's talk about like what using Toolbox with MongoDB looks like. So the first thing you have to do is define a MongoDB source. And for MongoDB, this is pretty short. You can just pass in a URL that represents how you want to connect, and that's all you need. That'll create a source for you that MongoDB that represents how you're connecting to MongoDB and is a MongoDB client under the hood. The next thing you want to do is define tools. So the way you define tools is essentially by specifying the things we talked about before. You can say the name of the tool is going to be find local customers. You can say what kind of tool you want. In this case, we're going to use the MongoDB find. The source is which MongoDB source this tool is going to execute on. So in this case, we're going to say the MongoDB find tool will execute on the my Mongo source. The description is essentially a natural language description. This gets passed to the model automatically. So as long as you're using an MCP client to interact with this, it'll pull in the description, it'll pass it into your prompt out of the bat. Next, we have a bunch of the things I talked about, which are guardrails, essentially limitations on like what exactly the application is allowed to control versus what the user is allowed to control. So you can see we have things like database collection. Those are limitations as to that the agent doesn't have access to. So they're things that you, the developer, can set. And then we have filter payload and filter parameters and project payload and project parameters. All of these parameters end up being exposed in the tool that gets created. So you can essentially define the exact query you want to run and then pass in a bunch of parameters that allow you to say, this is exactly how this tool will execute once it's started. And so using these tools from your agent is pretty straightforward. You don't have to redefine a bunch of Python functions like you would normally. You can just say, hey, I'm going to open up the client. I'm going to point it at the URL of my Toolbox server. That's going to give me a Toolbox client. And then from the Toolbox client, I can load tools or either by name, or I can load them by tool set to essentially get the tools in a way that my agent can understand. This works with almost every single orchestration framework. You can just pass in the Toolbox client, creates the Python function under the box, or in the case of like some of the orchestration, creates the proper interface. So you can define an agent very quickly. You can pass those tools in and essentially leave the hard work up to Toolbox. Right now, there's over 9 different types of tools for MongoDB. We have a MongoDB aggregate, which allows you to do a multi-stage aggregation pipeline. We have a delete many tool, which allows you to delete all documents from a MongoDB collection to match a filter. We have a delete one, which does the same thing but for a single document. We have find one, which allows you to find and retrieve documents from a MongoDB collection. We have insert many and insert one, that allow you to insert different documents. We also have update many and update one that allow you to update many or update one documentation. So you can view that QR code, go take a look at the MongoDB documentation in our Toolbox docs. We have different documentation for every source that includes instructions for how you can configure the tools and sources that you want to be able to use. So with that, I'm going to hand over to Mira for the demo.
Thank you so much for this overview. Yeah, if I can just share my screen. And this is the demo that we will use today. It is a very simple grocery shopping agent that I built with ADK and the MCP Toolbox. So let's see how it works. The ADK UI that is provided here is actually for the development server. So it has this beautiful chatbot UI. I can attach images. I can just speak to it. I can even record video. So it has these multimodal prompts that we're all used to now when using chatbots. So for this one, I'm going to attach a picture of a cake, and I will try to find the ingredients in my grocery shopping inventory. And as you can see, we actually see that something is happening. We got the initial message from the agent that this is an online groceries agent, and it will try to find ingredients for this delicious looking chocolate cake. And then it starts calling some tools. These are the tools that we will implement in the demo. So it finds similar tools. As you can see, it's called that tool a bunch of times because we need a bunch of ingredients to bake the cake. And when it succeeds, we actually can see what it got back as a response from our database. And these are all of the ingredients that it found. So you can see the list of ingredients, and the final message from the agent is, would you like me to add any of these items to your cart? Also, if you need a specific type of flour or any other ingredient, just ask. And I'm just going to say yes, add everything to my cart. And I didn't mention, but this is finding the ingredients from a MongoDB inventory database. And it's supposed to add these to a cart collection in my database as well. So let's see. To make sure I add exactly what you need, could you please specify which exact products you would like to add? I can just say add the best ones. Let's see what happens. Okay, I'll do my best to select highly rated and commonly used options for your cake ingredients. So actually in my database, I have a rating field for each item. So the agent knows that it can sort them by rating and then pick the best rated items. And as you can see, it called the add to cart tool a bunch of times for all of the best rated ingredients that they need. It succeeded all the times, and it added some of these to my cart. All right, what else can this agent do? Well, it can calculate the total of the cart, which is another database operation. So, yeah. So let's see what is the total of everything I added in my cart. The total is 1103. That's in Indian rupees because this is the data set that they used. So it might seem like a large number, but it's not that much. It's enough to bake a cake. It's about maybe $20 or $30. Is there anything else I can assist you with, or would you like to proceed to checkout? Well, that's a bit of a hallucination here because I don't actually have the checkout tool, but maybe I specify that in the agent instruction, so it's still asking me. And let's not forget to thank the agent, just in case something happens in the future. We want to be on the good side of the AI invasion, so we always have to thank our agents. All right, so this is the demo, and let's see how we implemented all this. I'm gonna open my implementation. So I have just a couple of files here. I have the tools YAML file that I use to implement the tools using the MCP Toolbox. And as you can see, I have three main parts here. I have the source, I have the tools, and then I have the toolset. So everything that you saw in Kurtis's presentation, we have implemented here. So our source is called MongoDB Groceries, and this is a MongoDB connection. I don't have my connection string here because I don't want you to see my actual production connection string, but you can very easily provide this. Then I have the tools. So what is the implementation of the tools? As you can see, I have three tools: add to cart, calculate cart total, and find similar documents. Let's start with the add to cart tool. This is a MongoDB update one operation. The source is MongoDB Groceries. Once again, this is our source over here that we're connecting to. We are adding a product to the user's cart. This is the description that we will give to the agent so that it can provide that to the large language model, and the model will know how to use this tool. Then we need to specify the database and the collection. So the database and the collection are coming, of course, from our source. Then again, we're doing update 1. So we have this card collection, and each user has their own card document. So each user has a card document, and every time we add something to the card, we are updating their card document. How do we find the card document? Well, we filter by the username. That's why the agent asks for the username. And this is the filter, and this is the parameter that we need to send. Of course, we are not sending this parameter. The agent will send this parameter, but we still need to specify the schema. And then we have the update payload. So we are adding a tool to the list of all the a product to the list of all products. So we are doing add to set. So you can imagine we have this document. The username is one of the fields, and the products is the other field, and the products is an array. And we're using add to set to append a new item to this array. So we are appending a product with a product name, a product category, and a product price. And you can see these are arguments that are passed by, again, the agent that is using this tool. And we have the description of this argument. So the product is the product name, the category is the category of the product, the price is the price of the product. And we have the specific types, of course. We don't want everything to be a string. We don't want everything to be a text. We actually want to have appropriate types for all of these fields. And finally, we have upsert true. So if there is no card document for this user, then the upsert operator will make sure we create a new document with the specific username and a new products array where the first item is the product that we're trying to insert. And as you can see, we're using YAML here, but we can very easily extract this and validate it, and also try to code this tool and make sure that we are, well, executing this in the right way. And we can validate that because it's JSON. Also, when you run the MCP Toolbox, it will give you back an error if you have something wrong with your syntax here. So don't be scared that this is YAML. You can still validate it, and you will get instant feedback if you got the syntax wrong. All right, let's look at the other two tools that we have. We have calculate cart total. Again, we have this cart document in our cards collection, and we want to sum the price of all of the products in the user's cart. Let's jump straight into the payload. This is an aggregate, so we are aggregating all of the array items. So first we match by the usernames. Again, we want to get exactly the card for this user, and then we are summing all the products' prices. And we return that as a new field called total. It's as simple as that. It's one database operation. And again, we have a parameter. This is the username, and that's everything we need. Very simple. Now, the most interesting tool is finding similar documents, and I wanted this one to be a little bit generic. So let's take a look at this one. So it's again an aggregation, and given a user query like chocolate cake or sweet treats, we want to be able to find similar products. We can't make exact name match here. We can't match by the exact product name because that's not how users will search. They will use some vague, semantically similar words. And that's why we'll use vector search. So vector search will allow us to use semantic search. So if we search for sweet treats, we want to be able to get back Kit Kat or donut or something like that. If we search for chocolate, but we make a typo, we want to be able to get chocolate powder mix or chocolate milk. So we will use vector search to implement this tool, and we will make it a bit more generic. So we have this aggregation, MongoDB aggregation again, and we have two stages. We have the vector search stage, and we have the project stage. So in the vector search stage, we will select the vector search index. Of course, we have already created an index on our dataset in the MongoDB database. We have the path leading to the vector embedding in our MongoDB document, and the query vector will be the vectorized user query. So if the user searched for sweet treats, we will vectorize that, or we will embed that and provide that vector embedding to our tool over here that is finding similar documents. So we're not comparing text to vectors, we're comparing vectors to vectors. And then we have a couple more parameters that are more specific to the algorithm that MongoDB runs to perform this vector search. And finally, in the project, we want to exclude the _ID field, which is more or less internal to MongoDB, so we don't want to send that back to the agent. We don't want that to somehow end up in the user output. And we want to exclude the vector embedding as well, because the vector embedding is a big array with a bunch of numbers, and we don't want that going over the network or somehow ending in inside the LLM prompt, because again, it's going to bloat the prompt, and we don't want that vector embedding to be part of the prompt. So we are excluding that from the result. The parameters that we have is the vector embedding. So this is the query that we vectorized and we are sending to the tool. And we will see in a second how we will generate that. Then we have the name of the index, and then we have the name of the field where the vector inside the document is stored. All right, we'll come back to this find similar documents tool because it's the most interesting one. But let's look at the two tool sets that I have created. So the first one is the queries toolset, and I wanted this to be more generic. So we have find similar documents here. And I'm not saying like find similar products or find similar groceries. I want to keep this one generic in case we want to reuse it across multiple agents. And I have a second toolset, grocery shopping toolset. Now this one is very specific. This is about adding products to the cart and about calculating the cart total. So it's very specific to our use case, which is grocery shopping. Now, how do we use these two tool sets? Let's go ahead and look at the agent implementation. Again, this is using the agent development kit by Google. And you can find the instructions for setting this up in the documentation. But what's more interesting is the actual implementation. How are we using this? So we need the Google API key. You can enable all the necessary APIs from Google Cloud and get your API key, add this to the environment, and run it. And then we are instantiating the GenAI client. And then more importantly, we are also connecting to our toolbox. So in the toolbox, we have all of our database tools, and we're connecting to that client. Now, how do we use the client? Well, remember we had that generic find similar documents tool. How do we use that? Well, first we get a user query. So we get this user query sweet treats or chocolate cake, and we can compare that query as text to our documents. We can perform vector search with it. First, we need to embed it. We need to vectorize it. And that's why we need another function called generate embeddings. And what this function will do, it's going to take this query, this text, and it will call a GenAI embedding model, in this case, Gemini embedding 001. We will provide the text, and we'll get back a vector embedding. Now, we'll return this vector embedding, and later we'll use this vector embedding to call the find similar documents tool. Now, find similar documents is, again, generic. We want something specific for our exact grocery shopping use case. And this tool will be defined here. It's called find similar products, and it is part of the implementation of the agent, but that's on purpose because we want this to be the specific implementation for this specific agent using the generic tool that we defined earlier. So this specific tool will get the user query, again, chocolate cake or sweet treats, or organic apples, another example, and then it will give us back a list of products that are semantically similar to the user's query. How are we going to do that? We'll perform vector search, and we'll get these results from the database. Now, first we need to generate the vector embedding for the query that is extracted from the user prompt. And this is switch reads or whatever. And then we will call the tool. So using the Toolbox client, we will load the tool to find similar documents, and then we will execute it. So we just invoke it as a function. We'll provide the vector embedding, we provide the name of the index, we provide the path to the vector embedding inside the document, and return the result. Now, if we take a step back here, imagine that this tool is something that you implement once, find similar documents, and then everyone in your company can use it. So you don't want to end up with having like 100 agents in your company and everyone implements their own specific tool that performs vector search in a MongoDB database. No, you want to share that. So you want to have this Toolbox client, and you want to have this tool set with generic tools that perform commonly known database actions. And inside your agent, you can make it more specific. So you can reuse this tool, but make it more specific to your particular use case. All right, let's go and see how the actual agent is working. So we have the prompt, the system instructions for our groceries agent. What it can do, it can help users discover and explore products. It can suggest alternatives. It can add products to the cart, everything that we saw in our demo. Then we will describe all the available products. I don't necessarily have to do that if I have good doc strings in my tool implementations, but I just wanted to make sure I'm not missing anything. So I have this description over here as well. Then I have some core guidelines for the agent, some instructions, and you can totally use GenAI to generate this prompt as well, to make it more specific or to make it more descriptive for your particular agent. Then we will load the entire toolset for grocery shopping. Again, remember this is this toolset over here for adding products to the cart and calculating the cart total. We'll load this toolset. We'll also insert the find similar products tool to our toolset, and then we will define the agent. So the model that we're using is Gemini 2.5 Flash. We have a name for our agent. We have the instructions. It shouldn't be indented right. And we have the toolset that we just prepared. And that's everything you need for the grocery shopping implementation. What is it, like 100 lines of code here, and a YAML file with 100 more lines of code. And it gives you this powerful grocery shopping agent. Of course, you can add a lot more tools. You can deploy that to Google Cloud, and you can do anything you want. If you have any questions, please type them in the LinkedIn or YouTube chat, and we're here to answer your questions. Kurtis, would you like to add anything on the demo?
No, I just want to call out, this was a really good demo. I feel like it showed a lot of the power and flexibility the Toolbox has. You showed, using the native Python function and embeddings and some more advanced journeys I wasn't expecting. So that was really cool.
Thank you. And of course, the whole idea of the Toolbox for databases is that you support multiple data sources. So imagine you're a company that has a bunch of databases for operational data and also for analytics. You can connect your agents to all of these sources and use a common tool set.
Yeah, I think another thing I'll highlight too is, I mentioned this earlier, but Toolbox is open source, and we accept contributions from the community. So at any one time, there's a couple dozen PRs open that folks are contributing new tools, and it just keeps getting better and better. I think this really builds on the multi-database aspect of it, because we see a lot of times that like someone for MySQL or Postgres will go and find an issue, and it applies to multiple databases or sometimes all of them. And so the really cool thing about Toolbox is that there's like this kind of joint push, which is that so many people are using it for so many different databases that they are adding new features and new functionality that is improving your use case specifically, even if you're not using multiple databases. And so the fact that there's like already a large community around this is a huge win, and is something I look for when I'm looking for developer tooling, because I know it's going to be maintained for longer. So.
Yeah, it's definitely always great to have that community backing. And yeah, I was definitely surprised when I saw 10,000 stars on GitHub for this project. It's always a great sign when it's backed by a community. And I mean, you're the lead for the product. What is your favorite item from the roadmap? What is something that you're looking forward to seeing in the toolbox?
It's hard to pick a favorite, especially when you put me on the spot. One thing I'll call out is you had a really cool example of wrapping a tool in a Python function in order to get the embedding. One of the things that we're looking into is a way to build that into Toolbox. So for example, you can say, hey, this parameter should be an embedding and it should use this model. And on the agent side, it'll look like a string. So the agent can pass in a string. But then on the Toolbox side, what we'll actually do is convert it into an embedding and then pass it to the tool before you. So essentially the little Python function that you wrote would essentially completely disappear. And this has a lot of really cool side effects, which is like if I have a bunch of agents that are using that, we can start doing things like caching, or you can update one model and it goes to all of the agents. So there's a lot of like really powerful things you can do when you have like this centralized tool server. And I think that's a good demonstration of one of the ways which we're kind of looking to leverage it. So
yeah, definitely. One of the things I get really excited about is the telemetry. When I read about it in Toolbox, can you share a bit more about how that's working and why is it useful for like a production agent?
Yeah, good question. So with the telemetry, it's kind of your standard open telemetry support. So all of the tools in Toolbox have telemetry spans and traces kind of out of the box. So what that means is you can pass a flag, you can export that telemetry to essentially anything. A lot of people like open source things like Prometheus and Grafana, or they like to upload it to their cloud provider. So like Google Cloud has a logging that you can upload open telemetry products to. And that allows you visibility into what's happening at a very local level. So you can see things like, hey, this tool call took this long. It was composed of, it took 3 seconds to execute this tool call. The first 1.5 seconds was trying to establish a connection with the database. The next 2 seconds were executing the query. And then maybe there was 0.1 seconds for processing the result and getting it into the format you wanted it to be in. And this is really useful because when things go wrong, you need that telemetry to figure out what's going wrong and why. So you can collect either individual stats. So when you're developing, you can see, okay, this is how long each section of this tool took. Or you can collect aggregate stats, which is oh, okay, I have this running in production. I can see that this tool call has been called, 10,000 times, and its success rate is 99%, or its success rate is 80%, and maybe we should go figure out why that 20% is wrong. You can dig into the logs a little bit and find some specific examples and see oh, okay, I see in this case, the agent's passing in the wrong parameters, so maybe I need to update my instruction. The telemetry makes that really easy to do, and the fact that we use open telemetry means it's compatible with probably everything you're using today, because I think open telemetry is kind of the standard around this stuff. So
yeah, definitely. Yeah, my experience with Google usually build these kind of open source frameworks and tools because they're also using something similar internally. Is that the case for the MCP Toolbox? Are you using that in Google, or
that's a great question. The answer is somewhat complicated. So we actually built Toolbox from scratch, aimed at external developers. One of my team's charter is really building ecosystems and integrations for our databases, for GenAI across databases. And so what we really wanted to do was, I would say 1.5 years, 2 years ago when we started working on Toolbox, what we really wanted to solve was the problem that everyone had a different tool calling paradigm. And we wanted to figure out how to make it easy to build tools, because a lot of people were building the wrong tools or the wrong shape, or they weren't secure. And so we wanted to figure out a way we could standardize and promote best practices. So we started working on Toolbox, and we actually launched Toolbox slightly before MCP came out. We had our private preview in October, and then MCP came out, and we were like, sweet, now we have a standard protocol that we can adopt. And so we added MCP support a few months later, and we've kind of just exploded in popularity, as MCP has as well. And so the entire goal is to try and make it easier to use. Internally, we have some things that have developed to look very much like Toolbox does today, and some of them are even more general. I think MCP in general has popularized this pattern, and so we're seeing a lot of different things pop up.
It's awesome. All right, if there is one place you want to send developers to in regards of MCP Toolbox, would that be the GitHub repo, or is there another CTA you want to?
Yeah. I think the GitHub repo is the place I'd recommend you start at. From there, you can find links to open issues, open pull requests. You can find links to our documentation. You can take a look at the code. You can feel free to open a PR. Like I mentioned earlier, we have more issues than we have people to work on them. So we definitely love contributions. We definitely love folks that want to contribute things that help make building things easier. So start by opening an issue if you have a problem, or look for an issue that somebody else has opened. Chime in on what would be helpful to you. Otherwise, feel free to look for open issues. We have lots of issues that are open, especially ones with help wanted that we think are good for folks getting started. Feel free to contribute and chip in, take a look at our documentation, and feel free to contribute.
Amazing. Thank you so much for this. Yeah, it was great to have you on the live stream. I think it was a very tight, very, very theory heavy and demo heavy live stream. And yeah, I'm excited about what's coming next for the MCP Toolbox.
Awesome. I would appreciate you being here. So thank you very much for inviting me.
And thanks for everyone who joined.